Good day. Today we are going to have lesson 2.4. It's about solving rational functions. Our memory verse is found in Romans 12 verse 1. It says, "Therefore I urge you, brothers and sisters, by the mercies of God, to present your bodies as a living sacrifice, holy and well-pleasing to God, which is your rational, which means a logical and intelligent act of worship." In this lesson, you'll be able to represent a rational function through its table of values, graph, and equation, and you'll be able to find the domain and range of a rational function and determine its intercepts, zeros, and asymptotes. Be sure to do the venture part before you go to the lesson proper. Pause this video as you check how many roots are there and what are the asymptotes of this function based on its graph. Now let's learn about rational function. Let's review the definition. A rational function is a function in the form of f of x equals p of x and q of x, where both numerators and denominators are polynomials, and the denominator is not equal to 0, or else it becomes undefined. Now let's start by solving or by finding for the domain and the range. Now, how will you find the domain of a rational function? These are the set of all the x values. So to find this, you need to set the denominator not equal to 0 so that your function will not be undefined. To solve for the range of a function, we need to locate all the asymptotes. Or another way is to find the domain of its inverse function. But since the inverse function is still in chapter 3, then we'll just do it by locating all asymptotes. We'll do it later since the asymptotes will be in the next lecture video. Let's just solve for the domain of the rational functions. Again, we need to, the denominator must never be equal to 0 so that the function does not become undefined. So for number 1, denominator x not equal to 0. So our domain will be the all real numbers except 0. Number 2, x minus 1. That should not be equal to 0. So x is not equal to 1. So our domain will be all real numbers except 1. Number 3, x squared minus 9 should not be equal to 0, but we need to factor this out. Based on your factoring lesson, the factors are x plus 3 and x minus 3, and that should not be equal to 0. So the first one, x should never be equal to negative 3, and the second one, x should not be equal to 3. So our domain is all real numbers except negative 3 and 3. Next, number 4. The denominator is x plus 2. That should not be equal to 0. We transpose it. We have x is not equal to negative 2. So our domain will be all real numbers except negative 2. For number 5, the last number, our denominator is x. So x should not be equal to 0. So our domain will be all real numbers except 0. This ends the topic on the domain of a rational function.